In last week's video we could see how I recut one of the surfaces of the saddle of this lathe. And I had to rework a little bit this same surface by hand, but at the end it worked. But the twist problem was still in place. And I found a high-tech solution to fix the problem. Sandpaper, 400 grit. What I did, primitive, by hand, just mark the surface I had to recut a little bit and then test fit, see where I had to grind off a little bit, test fit again, recut, retest fit, recut, about 2,800, that's not true, a lot of times. And as you can see, now the whole thing is reassembled and ready to go. So let's continue make this adapter. This little part we see here will become, of course, the thread. And first I will cut this taper here. So let's do. Looking good. Before I continue, let's take it out of here and do some kind of test fit. Because the dividing head has the same taper, it will make things a little bit easier. Oh, there is a little bit of wiggle in it. I just resetted the angle and gave it a light cut, only until here. This was the first cut, now it's only here. Let's see what happens. Ah, no wiggle, that's good. I see the thing touching here, and here's a bigger line, but I can feel it in the surface. But I think now we're good, so let's finish it. All right. As you can see, it is a very nice fit. And now maybe you're wondering, how the hell does he manage to adapt two different tapers and make them fit? But it's not complicated. Let me explain. This is more or less the situation, and here is our cutting tool, right, to cut this to be taper. Before we start cutting like a butcher in a piece of animal, first of all we set the cutting tool somewhere over here, right, and we put the 0 on the cross slide. Very important. And then back off, start cutting the taper, and then dial in, cut, dial in, and when you reach 0, automatically your taper will end here in this corner. I suppose that's not rocket science, and I also suppose you knew this trick, but of course it's not for you, it's for the other person that didn't know. So far so good. So maybe now it's a good idea to start thinking cutting the thread here on this part. And online I found some information that tells me that the angle of this special thread, I know it has a special name but I don't remember of course, combined angle is 50 degrees and this angle is 5. Of course I don't have a cutting tool for this, so let's make one. I have here a nice piece of high-speed steel and I already used it to make a special small tool. So now it's gonna be a thread cutting tool. And according to this information that I found that I hope is exact, you never know, combined angle 50 degrees. So I suppose one side 5 and the other one 45. I also installed here my diamonds. Let's make something. My brand new little cutting tool is installed here. Let's do a scratch pass to check if indeed the pitch is 2 millimeters. Oh, there is something absolutely wrong here. The pitch is more than 2 millimeters. Let's check the gears, which of course are hidden here in this kind of fridge. According to this chart here, for a pitch of 2 millimeter, which I need of course, we need to check chart number 1, this one. And my gears are in position 140, position 260, it looks like 80 but in fact it's 60, 374 and 436. Now it could well be that I have to switch 2 and 3 because for me it's not really clear which one comes in the front and which one comes in the back. And as you can see here, I installed the 72 on the front and the 60 in the back. So maybe it has to be the other way around. Let's switch. That's done. Now you can see here that the 60 is in the front. So let's give this thing a try. Nope. There's something completely wrong with my gear system. That's why it's always a good idea to do a spring pass and check, I suppose. Okay, I will bring you back when when I figured it out. And in the meanwhile, I did figure it out. Because some time ago I had a comment from Kevin. And Kevin, he commented to tell me that he has exactly the same lathe that I have here. And he did send me an email with all the documentation, with all spare parts list and all electrical systems. And that's where I found out in his documentation that indeed this gear should be 80 gear and not 60 as I thought it was. And because of the same documentation I also found out that this thing here you can fix the clutch system. I had here a big problem with the feed mechanism clutch and now it works. So Kevin, thank you very much for your documentation. Right, all that being said, I have to hold this project again because I need a 80 teeth gear to cut this thread, which of course I don't have, so I have to make one. And of course I don't have the material to do it, so I don't know when, but one day for sure. And the first part of this video that you just watched, I recorded it before I posted the last week's video on YouTube. And in this last week's video on YouTube, in the comment section there was an explosion of comments about the lathe carriage alignment and fixing the problem, and I think it's a good idea to have a little chat about it. To fix the twist problem I had here on the carriage, of course, and I didn't show it in the video, but of course I started from the beginning. And by that I mean, of course, checking the bed. So the ideal system is, of course, to take the whole lathe apart and put the bed on a surface plate. But no way. I don't have a surface plate and I don't want to take this whole switch apart. Out of the question. So I do the next best idea. I took off the chuck. If we start from the idea that this part of the bed has the most wear, because this is the part we always use. So over here, less wear. And if I take the chuck off, I can go completely against the headstock. I had a little brain fart, happens. And I installed a laser. This is a laser level, but I don't use the level, I just use the laser that comes out of here. And I project the laser point on the other side here of the garage, which is about 4 meters from here, on the wall. Let me show you. I don't know if you can see, but here is the laser point. I will go the other side of the garage again to the lathe and move the carriage. Laser point is right here, and the carriage is now at a spot which has the most wear. And I measured, because here is a pencil line, I measured here, I am 0.5 millimeter below this line, and at this spot I am 0.5 millimeter above this spot. which means 1 millimeter of difference in height over a total distance of 4 meters. I think that's a really nice result. Of course, my laser test here on the machine doesn't tell everything, but I think you have to start somewhere in precision and also stop somewhere in precision. And to illustrate it, I will use this part that I used several times in this video series. I installed it between centers and I gave it a sweep with the indicator to install the top slide at the right angle. And that's where I saw that in fact this surface is hollow. And I turn it a bit around and a bit more, and the indicator shows me hollow. But I know that the top slide of my lathe works perfectly fine in a nice and straight line. So I check the same part here on the table of the shaper, which I know is nice and straight and flat. And here indeed there's no rocking, no nothing, and by feel you can tell a lot. A human hair makes a lot of difference in feel. So here I do several times the test, and on the shaper table it is perfect. And just to be sure, I also put it here on my homemade surface plate. And here there is a rock in it, which means this part has a belly, and also here on the other side. But when I check my little surface plate, it is perfectly straight and flat. Knowing that this is an original decal part, and decal doesn't make junk, so I'm sure that this thing is straight. And I'm sure that my lathe is straight. And I'm also sure that the shaper is straight and that the surface plate is straight. One part, 3 different results. So when I started working here on the carriage, of course I took several different kind of measurements and feels, and because feeling you can do a lot with it. And that's where I saw that the back rail has a bow in it, 0.2 of a millimeter of difference. The front rail had a bit less than 1/10, and one rail was higher than the other one, so there was I don't know how to call it, some kind of strange twist in the thing. And the left and right movement, the twist movement here, was of course because of the wear on the front and back side. These two sides was more important than in the middle part. So first of all I took a piece of fine sandpaper, installed it here on the bed, taped it on, and then very carefully by hand started to grind, mark it with a Sharpie, grind again, mark it with a Sharpie. So I could see that indeed this surface and this surface were in match, in relationship. Of course, you're gonna say, because of the thickness of the sandpaper, there will still be a difference. And yes, you're absolutely right. But don't forget that this is a hobby shop. This is a just for fun machine. It's not CNC precise thing that has to make millions of parts. In an industrial environment, every 4 or 5 years they throw their machines away, buy new and start again. Of course, in the hobby shop, that doesn't exist. 90% of the parts I make on this machine doesn't have to be precise. So who cares, right? Okay. Back rail was more or less in shape, and then I started to work the V with the same sandpaper. Make it black, Sharpie, do a test fit, a little bit sliding, and then I could see where I had to grind off. And now I have a twist movement of less than 1/100th of a millimeter between the middle part, which is of course more or less the hinge, middle part, and I'm gonna say almost 200 millimeters. So 200 millimeters, and here we have a movement of less than 1/100th of a millimeter. I think for a hobby lathe that's more than good. I read in these comments that some of the viewers has exactly the same problems on the lathe that I have here, or that I had here. And they are not really willing to start because it's maybe a little bit delicate to do it. I don't see the problem. You can do anything wrong by taking your lathe apart and check what's going on. And double check, and then think about a solution, and when you've got it, rethink about a solution. And when you think you're ready to start doing it, rethink, recheck, just to be sure. And I think the best way to fix the problems is to do it by hand. So very slowly, take your time and go for it. Some time ago I took the table off for the shaper to cut a little bit a rim that was starting to form on the back side here on the sliding rail, and it started to leave a mark here. And someone commented that I did a lot of work with nothing result. Well, I politely disagree, because again, this is a hobby machine. And indeed I did cut a very tiny bit of this rim off, so it doesn't score anymore here, this thing. And one day it will wear again. So what? I will take it apart again and cut the same rim again. That's all. It's a hobby.